Hello, my name is Florina Muntenescu. I'm a developer advocate at Google. And today, I want to give you an intro in API usability. So usually, when we think about usability, we think about a UI, so a user interface. We think about an app like a mail client, or a photo app, or a Maps application. And what we want is for these apps to have several qualities. We want them to be intuitive. So for example, for a Maps application, we want to easily know how to navigate from A to B. We want them to be efficient, so we want to get those navigation directions as fast as possible. We want them to be correct, because we want to know that we're on the right path from A to B, without any roadblocks, for example. And we want those apps to provide the appropriate functionality. So for an Maps app, we want to be able to see the map, to zoom in, to zoom out, to navigate, and so on. And we also want appropriate access to that functionality. So for example, to zoom out, we just want to pinch the map. And actually, we want the same things from the APIs that we use. We want them to be intuitive, efficient, correct, to provide the appropriate functionality, and to provide appropriate access to that functionality. So if in the UI usability, the UI is the interface between the user and the functionality or the content of the application, in the API usability world, the users are now the developers. And then the API is the interface between the developers and that body of code that implements that functionality. So in the relationship between the end user and the application, we actually have a lot of people that advocate for the user. We have UI, UX experts, we have product owners, we have product managers, and so on. But for the API, for the developer API relation, we don't really have anyone to advocate for the developers. So it becomes our role to advocate for the users of our API. So actually, what I'm suggesting today is to, let's say, steal some of the practices, some of the learnings that all of these people like UI, UX experts, and so on have taught us about how to work or how to develop things for the user, and actually apply the same principles to API usability. So, okay, what's API? I think we're working with APIs every day. There are libraries, frameworks, tools, and most likely we're also building our own APIs. So if you're developing your own module in your application, so you can separate some code, and you're just providing maybe some classes and some methods that can be accessed from your application, it means that you're also building an API. And in general, APIs are the perfect way to reuse code, because like that we can build on top of what other developers have built before, actually maybe even what us developed before. So we don't need to reinvent the wheel every time we need that wheel. So the truth is that APIs are difficult to use for developers of all levels, from beginners to experts. We end up spending a lot of time learning how to work with these APIs. And furthermore, when these APIs are used incorrectly, we end up with bugs, or even worse, with security issues. And actually, we're taking different roles around APIs. We're wearing different hats. We are the ones that develop the API, we're the ones that use the API, and we're the ones that use the applications that contain those APIs. And for every role, we actually have different goals. So when we are the API designers, what we want is to maximize the adoption of the API, to minimize the support cost, to minimize the development cost, to build something that's extensible and easy to use, and to be able to release the API in a timely fashion. When we're the API users, so the ones that use the API, we want to quickly develop error-free applications. We want to use widely spread APIs because we want something that's already been tested, that already has all sorts of answers, well, questions and answers on Stack Overflow and other mediums, and for which sample code exists that we can just, let's say, inspire from. We also don't want to update our code whenever the API changes. And of course, we want our app to run fast and efficient. When we are the consumers of the resulting products, well, we're also affected by the quality of the code. So what we want as consumers is to have products with the desired features. We want high robustness and ease of use. And the truth is, bad API usability affects us no matter what kind of hat we're wearing. So what I want to do in the next minutes is to give you a better understanding of API usability. Like, what are the factors that influence it? And I want to take some lessons and best practices from the designers, and we want to see how we can apply the same UI rules to the API. And of course, in the end, we'll also see how we can further identify these usability issues. Okay, so let's start with the factors that influence the usability. The first one is the developer, the user of our API. So what influences the developer is its overall programming experience, because a more experienced developer might find similarities with other APIs, and therefore it can learn a new one easier. Next one is the developer's experience with the problem domain. A developer that solved problems with other APIs might find similarities with the new API. Therefore, it will be easier to use. Next one is the developer's experience with that concrete API. So a developer that already learned how to use an API will, of course, perform differently than one that uses it for the first time. And moreover, research shows that this is much more important than the other two, than the overall programming experience and the experience with the problem domain. Because when a user uses a concept for the third time, it already learned how to use it. And then afterwards, there's not really a significant improvement after that. So this means that usage is the best type of learning. The next thing that influences is the developer's discoverability and learning style. So discoverability takes especially long when a concept is used for the first time. But as soon as the user knows when to use a certain concept, where to find it, it doesn't need to spend the same amount of time to search for it. So speaking of learning, the next factor that influences the API usability are the API learning resources. So these are two main learning resources: the documentation, because an API should be well documented, and the code samples. So the role of the code samples have several roles. They should allow the developers to understand the purpose of the library. They should allow them to understand the usage of the API, but also the usage context. So we can separate code examples in three different types. The snippets. So these are small pieces of code intended to demonstrate how to access basic API functionality. Tutorials, which are usually longer and they consist of multiple code segments, and they form maybe a more or less complete application. And usually they're intended to teach developers some specific aspects of the API. And then the third type is the actual code samples, so bigger projects that you'll find in repositories. From all of these three, developers have a problem if they only have snippets available, because snippets don't allow them to actually see the bigger picture, to actually understand how those snippets come together. The third part that influences the API usability is the structure or the design of the API. So what I mean design is different issues with the API structural design and testing and debugging. So different issues related to APIs, testing, debugging, and runtime behavior. What I want to focus today is on API design. So let's see how we can evaluate the design. Well, once a new API is designed, we need to evaluate it to measure and improve its usability. So actually, we say that an API is more complex the longer it takes us to use it, so the longer time it takes us to use it. And the easiest way to evaluate something is based on a set of guidelines. So together with some general guidelines, I want to provide some small tips on how we can improve the usability of our APIs. So let's take 10 usability heuristics for the user interface design and see how they can actually apply also to the API design. So the first guideline is the visibility of the system status. So the rule says that the system should always keep the users informed about what's going on through appropriate feedback within reasonable time. So what does this mean in terms of API? To know what's going on, so we want to know the state, and this feedback is actually having proper error messages. So the operations should provide appropriate feedback. In terms of code, an example of knowing the state is when using Room. Room allows you to see whether your database is inside a transaction or not by just calling in transaction. In terms of error messages, in case you're accessing the database on the main thread, you'll see errors like this, like cannot access database on the main thread, since it will potentially lock the UI for a long time. So the API tells you what's its state, what you did wrong. Next guideline is to have a match between the system and the real world. Because the system should speak the user's language with words, phrases, concepts that are familiar to the user, rather than system-oriented terms. So what does it mean in terms of APIs? That names given to methods, classes, and the organization of methods into classes should match the user's expectations. Because when searching for a class, the users don't really have a concrete starting point. What they rely on is their knowledge of the domain. So, for example, when working with a database, we know that we want to insert some data, we want to query the database, we want to update some data, we want to delete it. So, for example, with Room, we have all of these annotations that actually match the expectations that we have from the database. Next is the user's control and freedom. So the user should be able to undo and redo actions. In terms of API, this means that we should be able to abort or reset operations, so we can easily get the API in a normal state. If we look at what the SQLite API provides, we see a long list of overridden query methods. And actually, it also provides a way of canceling a query via some cancellation signal. So it's kind of hard to use, to find it, but it's there. So SQLite database allows you to also get the database in the state you want if you decide to cancel the query. Next one is consistency and standards. Users should not have to wonder whether different words, situations, or actions mean the same thing. In terms of API, the main keyword here is consistency, because all parts of the design should be consistent throughout the API. So we should use consistent naming across methods. So let's say that we have a class that inside has two lists of observers, a content observer and a data set observer. And we want to provide a way to add listeners, to register observers. Well, we should really be careful and make sure that we add the same name for methods that actually do the same thing. In this case, just add an observer to a list of observers. Otherwise, it can be quite confusing, because you would be asking yourselves, what's the difference between register and add? Would register mean that I can only have one observer at the same time? So make sure that you have consistent naming, that you use register content observer and register dataset observer whenever you need it. Consistency also means consistent parameter ordering across methods. So let's say that you have a method that's called setNotificationURI that can get either 2 or 3 parameters. Well, if those first 2 parameters are the same, make sure that the order is the same in those 2 methods. Also related to parameters, functions with multiple consecutive parameters of the same type are difficult to use. So, for example, let's say that I have an address that has all sorts of details there, the street, number, zip code, and so on. Android Studio helps us with this because it quickly shows us what I should add in terms of parameters. But, well, knowing me, I can easily do things like this. So, for example, there, instead of calling city, county, country, I tend to just mix words and do Alt-Enter too fast. And, yeah, call wrong parameters by mistake. So a solution for this problem would be to use builders or wrap those objects or those parameters in other objects. And speaking of parameters, the complexity of a method increases with the number of parameters. That's why, well, research shows that the number of parameters should usually be less than 4. So more precisely, there's an exponential increase in complexity of the method with the increasing number of parameters. Because for each of them, the user not only needs to understand its meaning, but also its relationship to all the other parameters. So, well, in this case, also you could use a builder or wrap stuff around. Another thing that influences the complexity of the method is the return value, because the developer needs to know how to implement it, how to interpret it, and where to store it. So, for example, when you insert some data in a database, the SQLite API, but also Room, returns a long. What's that long? Is it an ID? Is it the number of rows that were inserted? If it's an ID, is it the same thing as the primary key? But what if my primary key is not a long? Yeah, things can get quite complicated. But the difference in complexity between the return value and the members is that the return values don't bother the developers as long as they're not used. So their complexity doesn't depend on their presence, but rather on their usage. So this means that the API designers are encouraged to return values to their methods, even when they're only needed in some occasions, because it only affects the usability when that value is actually used. So one thing that Room does well here is to also allow returning a void when you're inserting the data. The next guideline is around error prevention. We should create a design which prevents a problem from occurring in the first place. So, in terms of APIs, the API should guide the user into using the API correctly. So, the API should be easy to use and hard to misuse. It should be easy to do simple things. It should be possible to do complex things, and impossible or at least difficult to do wrong things. So, for example, in case of Room, if you're working with when you're building the database, you're using a database builder, and this builder has a method called fallback to destructive migrations. So in this method, if you're setting this method, it means that whenever you're changing your schema, your database will be dropped and then recreated. So this means that you're losing the user's data. But the default value for this is to keep the user's data, because like this, we ensure a good usability for the user of your application. We ensure that we're keeping the user's data. The next guideline would be recognition rather than recall, because we want to minimize the user's memory load by making objects, actions, and options visible. In terms of API, this means making names clear and understandable. Another rule is flexibility and efficiency to use. So you should allow users to tailor frequent actions. In terms of API, this will be translated as users should be able to accomplish their tasks with the API efficiently. So, practically, what does that mean? That we should provide a flexible API. So, for example, also with Room, when we're trying to access the database, when we're trying to get the data, Room can return either just the data, can return a live data of a data, it can return a flowable, maybe a single, and so on. But if you don't want to use any of these, you can even use an invalidation tracker to make sure that you're up to date with your data. So Room offers this flexibility of the API. It allows the developers to use it in the way they really need it. Next guideline would be related to methods. Methods are hard to find when they are placed in a class that has no direct relation to the code that the user has already wrote. So the thing is that switching between classes and information lookup costs the user quite a lot of time. And the most time-consuming operation is recognition. Recognizing classes and then the method that you want with the right parameters. An example of this is the database util from the SQLite database API. You actually have a lot of methods, and I actually recognized some methods that I wrote myself from the list here, just because I didn't know that this database util exists. You should avoid writing util or helper classes. The next guideline is related to the design and the aesthetic, or to minimalistic design. Your UI should not contain information which is irrelevant or rarely needed. In terms of API, it's about not exposing internal API logic, because this can confuse the user and can lead to incorrect usage of the API. So, for example, this is one thing that the SQLite database does well. It creates a static method to open the database, and internally it has its own open method that does all sorts of things. But if that other open method would be public, well, the dev user, the developer, will be even more confused, and it could lead to a lot of bad usability or bad situations with your database. The next rule is related to not making the user do anything that I could do, because this leads to boilerplate, and we all know that boilerplate is annoying and is error-prone. So, for example, with Room, if you want to do multiple operations inside one transaction, you can do a database begin transaction, you do your operations, then you're setting the transaction to be successful, and then you're ending the transaction. But if you have a lot of these kind of methods, you end up copy-pasting that begin, set transaction, and end transaction several times. So that's why Room created the add transaction annotation that you just add to a method, and Room takes care of all of that boilerplate for you. Next, you should help the user recognize, diagnose, and recover from errors. So error messages should be expressed in plain language, precisely indicating the problem, and constructively suggesting a solution. Well, if this is the UI rule, what does it mean for the API? The first rule will be to fail fast. The sooner you report a bug, the less damage it will do. So compile time is the best time. And if you must fail at runtime, do it as soon as possible. What Room is doing is, if you're writing a query that's incorrect, you will know about this at compile time. So you will get a message like this if you change or if you use a wrong table name. So the message will say there's a problem with the query because there's no such table, data. So you directly know what's going on at compile time without needing to actually run your application. Then speaking of exceptions, you should throw exceptions only to indicate exceptional conditions. The user should not be forced to use exceptions to control the flow. So also in case of Room, if you're doing database operations on the main thread, well, definitely that's an exceptional condition, and this is something that you should know as fast as possible. Also, you should throw specific exceptions and not just general ones like exception. And you should prefer existing ones than to API-specific ones. Like Room is throwing here an illegal state exception. And also, the message should be clear so it can precisely indicate the problem. So here it exactly says that, hey, you're doing stuff on the main thread. You shouldn't be doing that. Next guideline for the UI is help and documentation. The general rule is that the system should be usable without the documentation. But if indeed you really need one, it should be easy to search. In terms of the API should be self-documented. But the thing is that no matter how good an API is, it won't be used without a good documentation. So document every exported API element, every class, method, field, parameter. And also, the example code should be exemplary, because if an API is used widely, its examples would be a model for maybe even thousands of applications. And any mistakes that you're doing in that example code will come back and haunt you. So these are the 10 usability heuristics for the UI that we can successfully apply also to the API design. But now that we know the general rules, how do we identify the usability issues? So there are several ways of doing this. I'm going to talk about 3 of them, and they all have their advantages and disadvantages. So you can decide afterwards which of them you want to use. So one of them is API walkthroughs. So this is a low-cost method to quickly get feedback, and it can be used early in the creation process, even before the code was implemented. So what does it actually mean? The participants are invited to walk through some static code. Oh well. Yeah, and then they will need to describe what's going on there. So this method tells us or helps us answer several questions. Helps us answer how readable the code is that one would need to write to call our API. It helps us answer the question of how understandable the code required is to interact with the API. Also, whether the abstraction of the API is appropriate, whether the API's behavior and structure matches the user's mental model for the API, and how intuitive are the naming conventions in your application. So this API through a walkthrough process has several advantages. So it can be run easily in the development process because all you need to do is just have some static code to run through. It's fast and inexpensive, and because you don't really write any code, it's easy to compare multiple versions. But in the same time, it also has some disadvantages. It's unsuitable for complicated APIs, and to be honest, it's kind of unnatural because we're not used to just statically go through methods like that. The next one would be usability tests. This is actually a direct adaptation of the usability testing used in evaluating UIs. So it actually starts from the premise that if you're observing a handful of developers performing realistic programming tasks using your API, you can uncover usability issues. So this method also answers several questions, like what's the mental model of the developers when they use the API for the first time? Like how easy it is to get started with the API, whether the abstraction of the API is appropriate, whether developers find the names and classes intuitive, how and when do developers look for information related to the API, and also what kind of information is important or even missing from the documentation. If you want to use this usability test method, you need to have several things. You need to have the API that you want to test. You have to have the user scenarios and also the API reference. But the thing is that this method can be used in several stages of the development process because you don't really need to do the full implementation. You can also use stubs and already get results whenever you're not finished yet with the development. And you can still make changes with let's say, less cost. Another way of identifying usability issues are hackathons. So in hackathons, maybe internal and external participants are invited to spend 1 or even more days building a piece of software using your APIs. So here you can learn, you can answer some questions also, like how do users learn about and get started with your APIs? What's the user's journey to Hello World like? What are their biggest pain points, misconceptions, exceptions, and so on? What kind of resources do they use, either official or otherwise? And to what extent does your API ecosystem, so like the documentation, code samples, and so on, supports the new developers? And to what extent does your API fit in the larger context of the system? And also, are there any problems that developers meet when integrating with other APIs? Whenever you're deciding to do a hackathon, you'll need several things. You need a focus for the hackathon. You will need an actual working implementation because developers need to use your API, and also a plan for gathering the feedback. So hackathons are valuable because you can get the data at scale in a more natural context. But the problem is that you have several teams of people that are spread throughout the event, so it can be a bit more difficult to get insights than in a smaller scoped session. So just be prepared with a plan. But in general, what you should remember is that the API, developing or designing an API, it's not a solitary activity. You should show your design to as many people as you can and take their feedback seriously. And in the end, I just need to say that design is an art. It's not a science. There are no precise rules that you can really follow. You'll end up making trade-offs, but you should just strive for beauty and trust your gut, and always have the user, the developer user in mind. Thank you.